Let's introduce some motion. Now, up to this point, we have only talked about a single point on a circle, and that point has stayed where it is. It hasn't moved. But we can also talk about motion around the circle. So if you see here, if I am moving around this circle, I can talk about its motion in terms of its x and its y. So here's what I want you to think of. As I move, if I just think about the x value as I'm going around this circle. So I'm going around and around and around the circle. Notice that the x value is just going back and forth from the right to the left. It's kind of like as we go around this circle, the x value of the circle is just going like this. That's what the x value of the circle is, just going back and forth. Now, same thing with the y value. If we're just looking at the y value of this circle, it's just going up and down, up and down. So we could explain where a point is on this circle by explaining where it is x and where it is y. So if I say the x is here and the y is there, that tells me where it is on the circle. If I say the x is here, the y is there, that tells me where it is on the circle. So these two equations are here to describe how the x value on the circle moves and how the y value on the circle moves. Now, what I want you to notice is that these equations you've kind of already seen before. Don't let the w freak you out. If you take this pink equation and you solve for cosine, we get x over r equals cosine, which you've already seen in this lesson. That's what we started this lesson with. Same if you took the y value and solved for sine, you would get y over r equals sine. So this isn't anything new. It's the same definitions you've been working with this whole time. The only thing we're adding in is this w here. Now, here's the equation for w. W is explaining how quickly you move around the circle. So theta is how much of the circle you moved around in this amount of time. So say maybe you're on a Ferris wheel and it takes you 30 minutes to go around the whole Ferris wheel. Then you've gone 2 pi is your angle because you've gone one whole revolution around the Ferris wheel, and you've gone 2 pi angles in 30 minutes. So that would be your W, 2 pi over 30. That explains how fast you're moving around the circle. So those equations help us describe how a particle is moving, that motion around a circle, using the x value and the y value. Now we're going to use all of this to talk a little bit about astronomy. Let's assume the Earth's surface is a sphere, a perfect sphere. So I'm going to draw, well, that's a really crappy sphere. Let me try that again. Here's my sphere. Draw a little circle in the middle, make it kind of look 3D-ish. And I'm going to pretend that this is Earth. Now, any point on Earth can be thought of as an object traveling on a circle. So, if I take this point on Earth, this point travels around this circle, and it travels that circle in 24 hours, one day. Travel one full revolution around the Earth in 24 hours. So you'll notice if I'm up here near the poles, the circle I travel is a lot smaller. If I'm at the equator, the circle I'm traveling is a lot bigger. We're still traveling those circles in 24 hours, one day, but one circle is different than the other circle. One is bigger than the other. So what we're going to do is talk about a specific point on this Earth, and that point is 40.7608 degrees north latitude. Now, what north latitude means is if I have my initial ray and I move north on that initial ray by 40.7608 degrees, this point on the surface of the Earth is my 40.7608 degrees north latitude. And this point has its own circle that it travels around each day. So each day this point makes a revolution around the spherical surface of the Earth. So let's start by finding what the radius of this circle is. So that's what we want to find. What would the radius of the circle of revolution at this point be? So I want you to notice that from this, I can still make a right triangle. Boom. And I want you to also notice that the radius I'm trying to find is the same thing as the x side on this right triangle. Those are the same distances. I'm looking for this radius. That is the same thing as that x. So I'm going to call that a pink x so I know that they're the same. And that is what I'm solving for. Now we know with SOHCAHTOA, if I know either this side or this side of my right triangle, I can use SOHCAHTOA and this angle to solve for x. So let's read our last piece of information. We know the radius of the circle of revolution at the equator is approximately 3,960 miles. So we are now at the equator right here, and here's our circle of revolution. And we know the radius of this circle at the equator is 3,960 miles. So I know this radius at the equator is 3,960. So we just need to figure out, if we know that the radius at the equator is 3,960, what is that on my triangle? Well, since it's the radius of the circle, we may notice that's the same thing as this. This length and this length are both radii of this circle, the sphere. So if this is 3,960, then this will also be 3,960. Now I have a right triangle. Oops, didn't mean to do that black. Here's my right triangle. So I have got the x side, that's what I'm trying to find. And I've got the radius, that's what I have. So if I have x and I have radius, we know that's cosine. So cosine of this angle equals my x value, what I'm trying to find, that's the radius of the smaller circle, over my radius of that sphere, 3,960. And if I solve this for x by multiplying both sides by 3,960, I get this equation. Which you can just put into your calculator. Make sure you're in degree mode. Now, one other thing to note here is, remember, we said that this x value is the same thing as this r value. So I'm going to change x to r, because I said they were the same. And now I've found the radius of this little circle of revolution. So if you put that into your calculator, you should get 2,999.47 miles. So that is the radius of this little circle of revolution as it goes around the Earth. It rotates around the Earth every day. Now, let's use all of that to come up with the equations of motion for this circle. So the equations of motion are those x equations and y equations that we highlighted up here. So x is r cosine of WT, y is r sine of WT. And we just very conveniently found what r is, the radius of the circle that these points are traveling around. That's the radius of this circle that it's moving around. X is cosine, y is sine. So all we need to figure out is W. So I know that W is how much of angle of revolution I'm moving around in how much time. And I know the Earth completes one full revolution, which would be 2 pi angle, in 24 hours. One full revolution, that's how many angles it travels in this much time, 24 hours, which simplifies to pi twelfths. And that is my W. So those two equations describe the motion around this circle. The x describes the side-to-side motion, the y describes the up and down motion of how this circle is moving. So that is our very brief introduction to circular motion. We will talk about this more in lesson 2.3, but you are officially done with lesson 1.6. You can get started on your homework.